We start with a panel that is actually an exciting one because it's going to be very spicy, at least I hope so. And I have my good friend here, Moderator, that I hope he made a good job with the questions. So the next panel is going to be the Battle of the Languages, and is moderated by Mehdi Zerouali. Did I spell that right? Amazing. So I guess we can start. All the panelists can join on the on stage.
Thank you.
Good luck.
Thank you. It's on though. It is now. Beautiful. All right. Chairman, grab a seat. Yeah, it doesn't matter.
Go for it.
Russ is in the middle because it's better.
There we go. All right. Hello, everyone. We'll kick off with a quick round of intros. Introduced myself early this morning, so I'll be quick. Mehdi, co-founder and director of Sigma Prime, blockchain security and research firm. I'll pass it over to Harry.
Hi, I'm Hari. I'm one of the founders and the CEO of Spearbit and Cantina. We are an end-to-end security marketplace. We work with Uniswap, Coinbase, you name it. We work with them today. But before that, I used to build the Solidity compiler at the Ethereum Foundation. I work with a lot of engineers building Solidity smart contracts, and I'm happy to share my thoughts.
I'm Dave Grantham, currently on the security team at Polygon, but prior to this, I worked at Protocol Labs on the libp2p team. I was head of security at the Linux Foundation at Hyperledger for a long time. The reason I'm here for Rust is I was on the security team at Mozilla when Rust was invented. I ported the tool chain over to all the BSD platforms. I ran the tier 2 build servers for many years. Was part of the team that realized that C++ was the bug, right? So yeah, I think it's pretty fair to say that I'm one of the first Rust programmers that wasn't on the Rust team, because we had to learn it.
Exciting. Wolfgang.
Yeah, hi, I'm Wolfgang Grieskamp. I'm at Aptos Labs, where I'm currently leading the Move platform. What is Move? Move is the new smart contract language, and we will probably talk a little bit about here, which also comes with formal verification. That's what I actually did primarily before. I'm generally tackling the language Move right now at Aptos. Aptos is the L1 blockchain, which came out of the Libra project.
Exciting. Thanks for the intros. So this panel is around programming languages, and it's a bit of a tribal topic. Everyone has some sort of preferences. So I'm going to kick this off by asking Wolfgang if you could please tell us a bit more about Move and what perhaps sets it apart from Solidity. If you could highlight some of the key advantages of Move over other programming languages like Solidity when it comes to smart contracts.
Yeah, so I would say one of the key advantages of Move is, to be frank, that it's later than Solidity. It was created after Solidity, many years after. And it was around 2018 when Move was incubated at Facebook. At this time, they still called themselves Facebook, as a kind of long discussion process whether to use an existing smart contract language or whether to use Rust. And they concluded that there need to be a new smart contract language. And the main concern is very close to the objective of this conference, is basically security. So what differentiates Move from other languages, it has a virtual machine based on a pretty high-level bytecode, which can be fully verified. You can add loading time, add execution time, basically verify type safety, reference safety. So Move has a similar reference semantics than Rust, and other kinds of important safety aspects of the code. And you can also take the Move bytecode and easily decompile it back into source because there is no information lost in the Move bytecode. This also reflects in the fact that you can easily use tools like program analysis or formal verification on Move, because Move is basically designed for being analyzable and transparent.
Exciting. And I believe there's a new version of Move that came out very recently, Move v2.
Yep.
Would you be able to perhaps highlight the main differences that were introduced in this version compared to the first one?
Yeah, I'm glad to. So the new compiler, and I want to say right away, a new compiler is considered a big risk factor in the industry. We know that.
Oh, yeah.
The new compiler was created to basically unify the move verification or move prover architecture with the compiler architecture, which were developed independently back at Meta, but share a lot of commonalities. If you know a little bit about formal verification, you know that it's basically a compiler to an SMT backend. No? So you compile just to a different target language, if you want so, in a lot of complex steps. And that's really the same like compiling to bytecode. So that was one of the reasons. So we can innovate faster in the move space by unifying those both architectures. By the way, I forgot to say, that's also important for the move compiler. A property of move is that it's not finalized, no? So it's still evolving. And the compiler was also created to make it easier to evolve the language. We created move 2, which is a new version of the language, which has a couple of interesting aspects.
Thank you. I might change this up a little bit and go with you, Dave, if that's okay.
Sure.
If you could tell us why, in your opinion, Rust has become so popular amongst developers over the past decade when it comes to its security properties and security guarantees compared to the nightmare that you pointed at earlier, C++.
Oh, okay. So let me think. So I was a C++ programmer for my whole career. I've been a programmer since '94, so like 30 years this year. So
Wow.
Wasn't even born.
I think that the reason that Rust was popular or has been popular comes down to a couple of things. So like when we were at Mozilla looking at Rust, the goal was to figure out how we could slow down bugs, security bugs specifically, going into Firefox, right? Because like we got tired of getting just hammered at pwn to own every year.
Yep.
Yeah, F you, GeoHot. I like you, but I would flip you off. I'm not Linus. I'm not going to flip off on the stage. Anyway, so when we were doing this, you got to remember Firefox is C++ DLLs and JavaScript code flying in formation that looks like a browser. Okay? And so you either had to be JavaScript or you had to be C++. And if they were going to rewrite components in a new language, it would have to be a drop-in replacement for C++, which is exactly why, and probably the only reason why, Rust is a drop-in replacement for C++, that it can expose a C calling interface and a C ABI and all that stuff. That has certainly helped it because it allows you to incrementally change from an old code base and a mature code base to Rust. But I think at the end of the day, we all fight in our engineering teams, we all fight bad habits. And I think Rust is the first language that we can honestly say that bad habits generally don't compile, right? I think it was some very basic things like flipping the default mutability on variables to being read-only. You have to like explicitly say this is a variable I'm going to change, right? I think it's very opinionated and very unforgiving borrow checker also really hammered home sort of you can only have one mutable reference to something. Again, that's a bad habit that we all carried over from C and C++. It's like, oh, it's just a pointer. I'll just throw it around. Who cares? And which is, we all know, probably the source of most security bugs. And then, let's see, the last thing about Rust that I think was really cool is that there was, like, we basically accepted that the long time assumption that long compile times were a bad thing always, right? We were just like, look, no, we're going to do a ton of static analysis, and we're going to take a hit on our CI/CD pipelines, our compile times, and all that stuff for all of the wonderful static analysis results we can get out of this. And so at the end of the day, Rust is very programmer friendly. It's just highly selective as to who it thinks is a programmer. And it will mock you, but it will, if you persist, you actually end up being a better programmer and going from Rust back to languages like JavaScript or C and C++ or whatever, you're actually a much better programmer. So I don't know. I think that it eliminates whole classes of security bugs we've been fighting for decades.
Great.
But at the same time, it forces engineers to level up their skills. And in the end, you get better code generally out of it, and your engineers get better. I don't know. It just seems like the right thing to do.
That makes sense.
Right.
We're big
Yeah,
Rust
yeah.
fans at Sigma Prime, so I can't really disagree. But yeah.
Yeah, and then because you can just drop and replace it, you could rewrite a DLL in Rust and put it in to replace the C++ one. Everybody's like, well, why wouldn't we do this?
Yeah. In fact, Linux has officially accepted support for Rust.
Yeah, that'll be really interesting, right?
Yeah. We'll see
Like,
how that goes.
Rust as well performing as C++?
it is. It's exactly the same.
There are projects which come to a different conclusion. Not because of the language, but because of the way how people use the language.
Interesting.
Yeah, I would love to dig into that, but in rewriting components in Firefox, we found that there wasn't really any hit at execution time, but we did see things like the URL parser in Firefox, which was like an endless source of security bugs. When we rewrote that in Rust, the number of security bugs literally went to 0. It was like, it's done, right? Like, there's no more security bugs. I mean, at least for a brief while. I think there might have been some
Sounds
later,
dreamy.
but it went from like just a constant pain in the ass to like nothing.
That makes sense.
Yeah.
All right. I would love to save some time to take some questions from the audience. So I'm going to move to Harry. Harry, you've been involved in Solidity, probably safe to say, since almost day one. You obviously have a very strong security background in Solidity. So Solidity has perhaps the largest developer community when it comes to smart contracts and its ecosystem, but at the same time, it's probably the language that suffers from the most hacks. Over the past 5 years, we've lost a tremendous amount of money on on-chain smart contract exploitation. So from your perspective, what steps do you think developers should be taking to effectively mitigate or avoid these security foot guns?
So I will get to that, but I want to maybe like tell a wider point, which is, I love Rust. I love, when I was younger, I used to love Haskell, and Rust is practically like an object-oriented Haskell.
It is.
I think like Rust is great for building like systems level software, but I don't think Rust or even Move for that matter is well designed for blockchain applications. The safety advantages that Rust has built in, it doesn't even apply for blockchain, like period. Like I meet a lot of people that learned Solidity for the first time. That was their first programming language ever. They don't understand anything about move semantics, borrow checker. These are not the issues that the users are facing. And I feel like in that sense, building a programming language where you don't truly understand your users is it's fundamentally flawed. And this is a mistake that a lot of like compiler engineers make, where they like all this programming language. I love Haskell, but if I were to build Solidity to be like Haskell, then there would be no blockchain, there would be no smart contracts in the world. So Solidity made a lot of pragmatic choices in its design. It's extremely simple. You can talk to a lot of people here where they learned their first programming language was Solidity.
Of course.
So I think that's where a lot of the success of Solidity came from, making it extremely simple. A lot of the security issues that these languages solve, they don't really apply in blockchain. Like, for example, memory. Like memory is like ephemeral. Like after a transaction, you throw it away. So you don't really have to worry too much about memory management issues, which is a big thing in systems level languages. So a lot of the design choices in Solidity were made to like make it extremely simple to write code. It was purpose-built for building smart contracts. And as a matter of fact, a lot of the bugs are not necessarily an issue with the language, but rather bugs that you have when you write any software. A classical example is rounding issues. Okay?
Yep.
So if you look at the history of rounding in computing, you can look at many Oracle launches that failed because of a bug in rounding. The same thing in smart contracts. If you don't really pay attention to rounding issues, you can have a DeFi protocol hack. The bigger problem with the crypto is that it's such an adversarial environment where anyone can now come and interact with your software. It's even worse than even, I think, aerospace, where I don't think like when there's a rocket launch, people are trying to adversarially attack it. Whereas if you're trying to launch a DeFi protocol, billions of dollars on the line, people are going to be coming in and trying to find bugs in it.
It's unforgiving.
So I think the bugs, the kind of bugs that are in Solidity smart contracts, that will always be there in like pretty much every language. The kind of bugs that Rust and other languages solve are non-existent in blockchain, like memory management issues. I don't know a single bug in a DeFi protocol or some other protocol that is because of poor memory management. So to answer your question, the kind of bugs in Solidity are really logic issues, and you have to be extremely careful when you're writing code. You have to almost think about it as writing like mathematical code. Like you have to be very precise in your building software. And if you're coming from Web 2, you have this philosophy of building fast and breaking things. That doesn't really work in building smart contracts. You have to be very methodical about writing software. You have to plan out very, very well. And if you want to get good at security, I think the best way is to understand like how previous hacks has happened. There are ways to level up your security skills. If you are an engineer, you can do things like competitions or bounties. It's a good way to like learn about security issues. So I know that was a lot,
No, thank you. So if I were to summarize, the reason why we're seeing all these hacks in Solidity is not due to the language, it is due to the popularity of the language.
Exactly.
And I want to give Wolfgang an opportunity to react to that, because obviously Move is meant to bring in a whole set of built-in protections for safer smart contract development. So would you have anything to respond to what Harry just said?
Well, I mean, by the way, I love Solidity. No? I know Solidity quite well because I also built a compiler from the Move language into the EVM.
Oh, yeah.
And as part of that, I was getting acquainted with Solidity. My criticism would be not actually on Solidity, but on the EVM. So like the target of Solidity. No? And that influences a little bit back to the language. The problem with the EVM is that it's basically a low-level von Neumann architecture with memory. But even worse than that, the control flow graph is obfuscated by having basically indirect jumps over values on the stack where to jump to. No? It makes really hard to reason about EVM.
I like you. Like a real computer scientist looked at it and was like, I don't know about this.
So, I mean, definitely, I have a lot of appreciation for the yellow paper. No? So, and it's a great piece of work. And it started this industry, but it was not written by a compiler specialist.
Yes, right? Obviously.
So that's unfortunately like a weight which Solidity and EVM has to carry, which is hard to remove today. No? That would be my main.
Thank you.
I mean, I agree, like in that sense, where a lot of the Solidity like quirks come from the EVM. Yeah. We have to be somewhat close to the EVM. We have to optimize the language so things are optimal in the bytecode. So you have to make certain design choices that make sense if you understand the EVM, but may not be as intuitive. And as a compiler designer, you have this question where, okay, you can make the intuitive thing, but it's going to be way more expensive, or you make the most optimal thing. So this is like the hard design challenge where people want to optimize for gas, people want things that are like efficient, and you have to make this trade-off of like, do I make this intuitive and make it less efficient, or do I make it very close to the EVM and maybe add some quirks?
That makes sense. I asked you how to upskill in terms of security. You had great answers, contests. There's a lot of resources now in Solidity. I want to ask the same question to these two gentlemen. If someone was to try to learn Move and secure Move development, what would be the perhaps 2 resources that you would like to point them to?
How it compares to Solana? I'm sorry.
Best resources to learn how to develop safely in Move.
Okay. So this is indeed always difficult. If you have a new language, you need to come up with the templates and the patterns to use it.
Yeah.
And I would not doubt that, so basically Solidity is more advanced here at this point of time. No?
Of course.
Of course, no? Because of all the because of the size of the
that
market.
Makes sense. Yeah.
Because of the long time it was there. So we're working on it no? And we're getting better. But we have the advantage that we can create tools easier.
Okay.
And those tools can be based on modern ML techniques like LLM or so, but they can also be on synthesizing or analyzing the actual code. No? And so yeah, so like I think in the long run, I would better move. But who knows?
Okay, same question to you, Dave, if that's okay. I mean, we keep hearing that Rust is hard, right? It's a very steep learning curve. Do you have an advice for people watching or here in the audience who are willing to spend a bit of time to learn Rust and hopefully learn it securely?
Yeah, so, I mean, there's a ton of really good resources out there about writing secure Rust and like understanding it all. I think the reason why people say Rust is hard is because it looks like an ALGOL family language, and it isn't, right? You have curly braces, you have parentheses, all the things, so you think, oh, it's JavaScript, oh, it's C++. It is not. It is an ML-based language that looks like an ALGOL language. And so you have to think that it was originally designed to be a functional language, which is why he was saying it's like an objective, like Haskell. And so you have to be willing to break your brain, and you have to program it in the way that you realize that a lot of your habits as a C or C++ programmer or even a JavaScript programmer or whatever don't necessarily apply. All the things they told you were supposed to do in computer science class in college, like you need to make a smart pointer to manage your memory, you need to do proper error handling, all that stuff, Rust will 100% punish you until you do that. And so you just need to go back to the fundamentals of what you learned in university and just accept that, just embrace it, because it's really about forcing you to do proper things as a software engineer. I know I sound like a Rust fanboy, and I am, but I'm going to be honest that Rust has a very dark side that I don't think a lot of us are talking about, which is the compiler is amazing at telling you you suck as a programmer,
Yep.
and so it forces you to be better. But then we have this other tool, Cargo, which for some reason didn't carry the same like paranoia that the Rust compiler has into the CI/CD, your dependency management, all that kind of stuff. Like, you would expect that Cargo, when you're updating a dependency, would somehow be able to diff, like do a delta and say like, this dependency from this minor version to this minor version, 60% of the code changed. Like, you should not trust this anymore, right?
You
like,
really want to upgrade?
Yeah, but it happily will do that. It's like, oh, who cares? It's the new version. It doesn't matter. It's been completely rewritten. It's full of backdoors and all kinds of really terrible stuff. And so what I'm getting at here is that we have this really amazing compiler that makes you a better engineer, writes code that eliminates whole classes of security bugs. And then we have this build management tool that it uses hashes maybe, to track versions and stuff, but you would expect it to reflect all the best practices in dependency management, software supply chain, security, auditing, all the auditing things we do. Like, what was changed in these two versions? Was there anything related to memory management, anything related to secrets management, anything related to cryptography, anything like, I just think Rust could be infinitely better on this front. Instead of it just being yet another build tool, you could leverage, in theory, the compiler's static analysis capability so that when you are updating a library, it is able to detect that there are, cryptographic algorithms in here that are being modified. There are, basic types that are being modified, like fixed size arrays have changed size, right? So all of the type assumptions that we have all through our code have to be revisited now, because this isn't 20 bytes, it's now 24 bytes or something like that. And I don't know, I love Rust to death, but Cargo needs some serious work.
Thanks for the transparency.
Yeah.
Can I add something to like the earlier comment? Like, I think to truly appreciate Rust, I love Rust, but to truly appreciate Rust, you need to write C, and then you need to write C++. Yes. And only after writing, C and C++ would you like really appreciate like Rust. Like, if you are a new programmer and if you were to learn Rust, like what the hell is a borrowed checker? Like, it makes no sense.
Yeah, why would you do that, right?
Yes, it makes no sense. And then but if you write C, like, it makes a lot of sense. And if you write like C++, it makes a lot of sense. So the way the Rust language was evolved and designed was to solve the limitations of C and C++. And you can only truly appreciate Rust if you
suffered.
See the pain. Yes, exactly. Like, you need to go through like a lot of segmentation faults in C. You need to like be able to debug a lot of things. I'm like, what the hell is going on? Why is my memory getting leaked? And only then you would truly appreciate Rust.
Being repeatedly humiliated at Pondo.
Can't disagree. I want us to take a bit of time to talk about compiler bugs, if that's okay. And how to prevent them. Not too long ago, there's been a compiler bug in the Sway compiler, which resulted in funds being stuck in a lending protocol, Swayland. Compiler bugs can be really, really challenging to detect, especially relying on traditional testing techniques. So I'm just opening it up here to see if you have any thoughts on how we as an industry could be doing better at detecting and hopefully preventing from arising in the first place these type of bugs.
I think, go for it.
Oh,
No,
I can just say, like, we created just a new compiler, no? So we definitely thought deeply about this problem. And we also were advised by our security company, Autosec, about it. So you need to come up with a new testing approach. No? What we're basically doing is comparison testing on all the transactions which were ever executed on our blockchain. No? So every single of those transactions will be running through the old compiler and the new compiler. No? So that works if you create a new compiler. If you create a new feature in an existing compiler, which I think this, I don't know whether that bug we are talking about was caused by that, but that is indeed a different problem. So there is really no silver bullet, a part of being extremely careful to roll the thing out. That's what we're also doing, by the way, with the new compiler. We have done it basically already half a year ago, but it's still not activated by default. No? Right. So you have to do it for a long time. I remember when I was at Google, when there was basically switching from GCC to this other C compiler architecture. I forgot the LLV, not LLVM.
LLVM,
right? Yeah, C-Lang, right?
Yeah.
That took them 2 years or 3 years. No? So that's what they took the time for rolling or switching the entire company. So it's just very difficult, but and laborsome and takes long, but it can be done. I think.
You know, Rust exposure to compiler bugs is like several layers, right? To make it, to be able to say that it's legitimately a Rust bug would be just a front end bug, right? And they're very transparent about changes in the front end. In fact, I think for the last few years, Rust's front end has really just been about adding sugaring, desugaring, right? Like, you know, async await actually just desugars to, it's just a shortcut for like some pedantic Rust underneath it. And so they're not really changing the language itself, but we are exposed to LLVM bugs, right? Because that is the backend. And I honestly, as an engineer, I don't know that there's a way you can prevent them. I think Google's approach to finding Chrome bugs could be really helpful here, where they just they have headless Chrome instances, millions of them, and they just load web pages and they look at the memory footprint and the execution context and do we ever have a pointer jump out of seg faults page, all this stuff, right? And so I don't know. I think what we could do is baseline a certain version of LLVM, like Wolfgang was saying here, is like once you have one that you fairly well trust because you fuzzed the crap out of it, that anytime there's a new update, you kind of make this managed transition from an existing one to the new one. You're compiling in both, you're comparing the differences, you're running all kinds of fuzzing operations on it.
Yep.
It's really tough. I mean, I don't remember what the guy's name is. One of the Unix guys, wrote that famous paper, like, how do you trust the trusters or what, it's about compiler bugs. You could actually inject something in a compiler to put backdoors into software. So I don't know. You just kind of have to fuzz them, I think, honestly.
Yep.
To gain some kind of trust. You just
Harry?
have to throw all kinds of junk at them and see.
Any thoughts?
I mean, first of all, this is my nightmare.
Your nightmare, yeah.
Yes.
Yes.
I would, ship a PR and if there is a mistake in it, in Solidity, there's like billions of dollars.
Of course.
Okay. So it's a nightmare, and we put a lot of work into securing Solidity. And you can see the results, like there are 0 code-gen bugs in Solidity that was discovered in on-chain. So nobody has ever found a bug that could be traced back to a compiler bug on the mainnet. That is not the case for other languages. There was a redundancy bug in Viper, a recent ABI bug in Sway, nothing like that in the Solidity history. And we put a lot of work into engineering the compiler, so like we wanted to have like 0 code-gen bugs. Couple of things we do. Like first of all, like the entire compiler is kind of simple and it's self-contained. We don't really have too much external dependency. We get a question a lot, why don't we just use an LLVM framework or something to build the Solidity programming language? There are multiple issues there, but one issue is that, okay, you're introducing an external dependency of something that wasn't even designed for the EVM. So that by definition adds a lot of unnecessary complexity. So we have avoided adding too many external dependency. Like we tightly control like the entire like code generation pipeline, and we kind of understand the entire stack. We made the compiler quite simple. We have purposefully designed a lot of things, so it's easy to write. It's easy to write the compiler. And lastly, we do a lot of fuzzing, and that's been quite effective. So Solidity has, there are some advantages in how we build the language. The first thing is we put a lot of assertions into the code generation pipeline. The entire pipeline has a lot of assertions. And what we can do with these assertions is you can create random Solidity programs. You have the grammar. You can use a fuzzer to generate random Solidity programs. And you can try to compile it. And you can see if one of the assertions would fail. And this is extremely successful in finding bugs before it goes into production. The other thing we do is Solidity has 2 different code generation pipelines. And when you have 2 different code generation pipelines, what you could do is you can generate random Solidity programs. You can compile it in 2 different pipelines. And now you can send random call data into it. And you can now compare if the state is different in two different like code generation environments. And this is also very successful in finding bugs before it gets into like production. And we have discovered many bugs that would have gone into production this way. We have also discovered bugs that we know exist in actual compiler, but it's very, very hard to trigger it. Like a lot of the time with fuzzers, they generate code that a human would never write.
Yeah.
So fuzzing, very useful. Building with the mindset of like, building a secure compiler is very important. Making sure your dependencies are small so you understand what you're building is important. Writing a lot of assertions and trying to, like you would rather have Solidity fail than generate bad bytecode. So sure. Solidity is built with that mindset.
That makes sense. Bhargav has been doing tremendous work over the years with the Ethereum Foundation on securing the compiler.
I'm impressed.
Out to him. Yeah. I think, can we take maybe one or two questions from the audience? Yeah, you go.
Yeah, I have a question. Actually, I really enjoyed because, like, as an application developer, like for me, it's really interesting to understand like the thought process behind like the development of compilers. So one thing I felt over the years with Solidity, especially because I have been working with Solidity since, I don't know, 6-7 years. It was like Solidity 3.0 or something like that. But recently, I'm also starting to take a peek into Move, so that's pretty interesting as well. One thing I felt over the years is kind of getting better on the Solidity side is that sometimes I felt kind of a disconnection between what the compiler developers or even at a lower layer, like the infrastructure developers have in mind and the actual needs of application developers. And so many times I ended up like swearing and why the hell this thing is implemented this way. I could have much more enjoyed one example, the custom errors that were introduced.
Yes.
I loved them and I hate them because I hate the syntax, but I love the idea. So now it's better. But back in the days, like using the custom errors would have forced me to rethink completely the structure of the error handling that we had in our protocol, and we ended up not using them, even though I love the idea. So how do we improve on this aspect? How do we get better in to make so that the experience for application developers is better, because that's also helps in writing secure code?
I mean, I totally understand where you're coming from, and so I personally believe there is an opportunity to make Solidity 100 times better than it is today. And people just need to work hard on doing it. And I'm very, I don't work at Solidity anymore. It really pains me to see like the slow pace of like how things are done. But there is an opportunity to make it 100 times better. The customer is a great example because we shipped this feature. It worked, but certain other features did not work well, when it comes to customers, like try-catch, for example. Yeah. And try-catch is a great example of like a language design that is optimized for the EVM, but it's not optimized for the developer. And this is like the challenge that we have to do. Like, there are ways to implement the try-catch so that it's very like obvious to use for the individual developer, but it's going to be much more like gas. It's very inefficient when it comes to like gas, whereas the current implementation is like very tightly connected to the EVM. So this is, I personally think we should have done the other way, like, optimize for the developer, but the team wanted to make it like to be very close to the EVM. So this is like one challenge we have to always face, like we have to make it intuitive, but also optimal and very closely tied to the EVM. And the EVM is also somewhat stagnant recently. Like right now we are making some improvements with the EOF, but in the last 3 or 4 years, there was no major changes in the EVM that actually improved the compilers or languages. So that was also like one constraint we had as compiler engineers. Like the Ethereum community was entirely focused on the merge, which meant no other thing could be done to improve the ecosystem. So there was a massive backlog of EVM changes, EIPs that could not get in, and all the compilers had to just do with what we have.
Makes sense. Yep, at the back.
Hi, I have a number of questions, but I think the most important one is for Wolfgang. I'm a fellow Move developer, and I think one of the major criticisms within the ecosystem is multiple chains use Move. First was DM, now DM doesn't exist. Now Sui and Move, and I think another Cosmos-based chain use Move. And there's major differences in these compilers. And that's one of the major, I've said major 3 times, but it's like, how I think somebody who's in the senior development of the Move language on Aptos, how would you address this criticism? And is there any initiative to try to make these compilers agnostic and like be kind of bring this ecosystem together?
Yeah, let me paraphrase. I think you are wondering about the Move dialects, no? Right?
Well, Sui and Move on Sui is different than Move
right.
on Aptos.
So the different Move versions. No? So to say the first year of the startups, Misten Labs and Aptos, we actually closely synchronized the 2 language versions. So there were, that Sui already has a different Pro model from the very beginning, which is completely based on objects and not on storage like Aptos Move is and also Solidity is. No? Anyway, so like we tried to synchronize that, but then we recognized in order to evolve those things and innovate in the space of languages, it doesn't make sense to always have it's very difficult, to agree on language design things. It can take years until you agree. So you discuss a really long time and whatever. So we decided it might be better that we can evolve and innovate independently and maybe synchronize every now and then. And we did, for example, for enum types, which were recently introduced both in Sui and in Aptos. But we also recognize that there are basically different approaches, and in the hope that we eventually consolidate it. But yeah, so I totally get what you're saying. It's just not practical for us in different companies to have to synchronize basically on every step. no? Because we are still evolving the language. The language is not done at this point of time. Yeah.
Do they all have the same base? Do they all like fork from the same code base, or are they like entirely different implementations?
They're basically very similar or the same in core aspects, no? But basically, the model, how the blockchain is programmed in Sui is different than in Aptos, or it was back at Libra and DM at Meta. So they choose more like a Solana model, I think, where you have basically, you cannot access storage from a contract. You have to declare upfront what the inputs are. And we found that model too restrictive. And I don't want to really talk bad about our colleagues or former colleagues. No? So I don't want to, we just thought it's not the way how to do it. No? And that's where this divergence basically started. No? And from these different program models, there are different requirements which are coming to the language. And that's what's happening right now, yeah.
All right, unfortunately, we're out of time. We could probably keep going for another hour. But thank you so much for our panelists. Give it up.
Thank you, Mehdi.
These great engineers. Thanks for sharing your insights. I'm sure they'll be lurking around. So if you have more questions around their languages, their respective languages, go grab them, ask them questions. And yeah, what are we on to next?